The Universidad Tecnológica de San Juan del Río, as well as the authors of this project, Gregorio Rodríguez Miranda and Guillermo Mendoza Hernández, thank Cier the opportunity to present the desktop version of Portable Forklift Simulator. The development of a portable desktop forklift simulator created by the Universidad Tecnológica de San Juan del Río using the iterative and incremental methodology presents a system that allows users to operate a forklift, handle loads, and navigate through a virtual industrial warehouse, with testing done to evaluate its realism and effectiveness in operator training. This is due that operators' training may not be completely effective or comprehensive. Operators who are not fully prepared or trained to operate a forklift may face serious difficulties when required to perform tasks under pressure, making mistakes that affect personnel, facilities, equipment, productivity, and costs. The development of a desktop forklift simulator aims to revolutionize training in industrial equipment, enhancing workplace safety and training efficiency by offering a safe environment that aims to train an operator to face the future challenges of the industry. The iterative and incremental methodology that was used in this project is based on the principle of dividing the project into small phases or iterations, where each phase adds a new feature or improvement to the final product. In each iteration, the work team develops a part of the project, finding errors, fixing them quicker, and enhancing the project with new functionalities. If a client request arises during development, these can be incorporated into future iterations, facilitating constant innovation and optimizing the development process. The objective is to develop a desktop portable virtual forklift simulator for training in the manufacturing industry through the use of devices with keyboard and gamepad control. The project not only seeks to perfect the simulator system, but also to provide a more realistic and functional virtual environment that allows operators to face a variety of situations in a safe and controlled manner. The users have two options to control the forklift, with either using a keyboard with the WASD to control the forklift itself and the arrow keys to control the forks, or a gamepad to control the entire device. The menus were redesigned, specifically in the arrangement of the buttons. Previously, they were placed vertically, which made them difficult to see and use. They are now organized horizontally, improving clarity, facilitating navigation, and providing a more comfortable and accessible user experience. The project currently has three levels. In the level 1, the difficulty is low, and it is intentionally designed to serve as an introductory phase to the virtual environment and forklift operation. The user must navigate through the entire virtual warehouse, collecting coins distributed through the circuit, which promotes learning in a dynamic and playful way. At the end of the level, there is a time counter, which indicates how long it took the user to complete the course. In the level 2, the difficulty increases considerably. In this scenario, the user must transport a load from point A to point B, following operational protocols more precisely, as the level will automatically restart if the user makes a serious mistake. This forces the user to maintain a higher level of concentration, precision, and care in their environments. The level 3, the difficulty continues to arise in this level, as a test of all the previously learned abilities. Here the user must keep using the forks to lift the loads onto a trailer. There are a total of 9 loads to be placed in 3 different trailers in this level. A series of performance testing was made to test stuff like main menus, structural scenarios, development levels, and final scenes of each level, with each of these components on functionalities and usabilities responding optimally. Besides that, each level had a series of tests done to check for the abilities that the players were learning, such as the time it took them to complete the level, the amount of mistakes, as well as the user experience, taking into consideration how much they actually learn to move around and complete the tasks given. In second level, the amount of loads completed were also taken into consideration. And lastly, in the level 3, which was the longest one, there was a specific care taken to note how difficult it was for players and how many mistakes they actually made trying to complete the level. There was also a series of general tests done, such as the ease of use, the graphical fidelity that players could experience on these levels, and the amount of learning each player achieved during the testing. In conclusion, the portable virtual reality forklift simulator proves to be an effective and functional tool for operational training in controlled environments. Users can interact with realistic environments that replicate situations typical of heavy machinery operation, allowing the development of essential skills without risking their safety or that of others. This simulator represents a significant advancement in the application of virtual reality technologies in the industry, offering an innovative, safe, and efficient alternative for forklift training. Thank you for listening.